Good afternoon, everyone. I am going to present to you the problems presented to you last time, its solution, and how to determine the correct answer in the series and sequence or sequence and series problems. So, here in the sequence and series problems, one of the problems that was not answered well is this problem: find a possible formula for the general term of the sequence. We have given 1, 8, 27, then we have 64, then 125, and so on. Okay, so if you will try to look at the given terms of the sequence, so our n here, we have the first term n, this is our n, 1, the second term n, this is the third, the fourth, and the fifth. Okay, so using our a sub n as our known as our general term to be considered, so this speaks of our a sub n, so the 1, 8, and so on, no? So you can say that your a sub n is simply your n be raised to the power of 3, because when you raise 1 to the power of 3, so example, 1 cube is 1. And if you consider 2 cube, that is 8. And then 3 cube is 27. And if we have 4 cube, that is equal to 64, and 5 cube is 125. Therefore, our answer there in the given activity was a sub n is equal to n to the power of 3. So that is our answer. Now, another problem that was not answered because there was a trouble with the what is this in the marks of the symbols used in the formula, excuse me. This is it, this is the problem. We have find a possible formula. For the general term and of the sequence given we have negative 2, then we have 4, then negative 8, then 16, then negative 32. So we have several choices presented, but our answer will supposedly a sub n is equal to negative 1 to the power of n and 2 to the power of n. Because if you only tried it, even if this was raised to the power of 2, and then you tried it, you know already what's your n, because this speaks of our a sub n, and our n is this one, what, first n, second n, the third n, the fourth n, and so on and so forth. So if you're going to do that in the first a sub n, the value is negative 2. No? So negative 2. So you have negative 1, and then you have to consider that that is a sub 1 is equal to negative 1 to the power of 1, 2 to the power of 1. So negative 1 to the power of 1 is negative 1. And then 2 to the power of 1 is 2. Therefore, negative 1 times 2 is negative 2. So that speaks of our first term as given in the problem. The second term. The second term, a sub 2, using the formula among the choices given, so you can substitute immediately to reduce the number of minutes you might solve the problem. So you can have negative 1 to the power of 2, because this is the second term, times 2 to the power of n, which is also 2. So negative 1 times negative 1, because that is 2, so that is positive 1. Multiplied by the next part, which is 2 times 2 is 4, and 1 times 4 is 4. So that is why from the given it's 4. Let's try the third one. It's 3, negative 8, the third term of the sequence. So let us try to make use of this one, no? So which is expected to be negative 8. So a sub 3 is negative 1 cube, because that is our n, and then times 2 to the power of 3. And negative 1 times negative 1 times negative 1 is negative 1, times 2 times 2 times 2 times 2 times 2 times 2 is 8. Therefore, it is negative 8. So our answer there is our formula that is supposedly be the right one is a sub n is equal to negative 1 to the power of n, or that one, no? Times 2 to the power of n. Okay, so that is supposedly our answer in that number. Okay, so the next part now, the next problem that I would like to share to you is this one. Okay. Find the common difference of the given sequence. First one is a sub 1. Next is a sub 1 plus 2d. Then a sub 1 plus 4d. Then a sub 1 plus 6d. Okay, the first difference, d is equal to a sub 1 plus 2d minus a sub 1. So, that is a sub 1 minus a sub 1 is 0. So, what is left is 2d. So, this is our first difference. So, to prove that it is really 2d, then you can choose a sub 1 plus 4 with a sub 1 plus 6. So, a sub 1 plus 6d, that one, and a sub 1 plus 4d. Now, a sub 1 minus a sub 1 is 0, and then 6d minus 4d is 2d. So, actually, our d now is 2d. So, that's it. That is our answer in the given problems, the three problems that we have. Okay, so we have the geometric sequence. We are asked to find the geometric sequence, the first three terms of the geometric sequence. The next problem, this is the last thing that I would like to share to you, is find the first three terms. Find the first three terms of the geometric sequence. Where a sub 1 equals 3 and the fourth term is equal to 24. Okay, so a sub 1 is 3, a sub 4 is 24. So we're going to find a sub 2 and a sub 3 because we are going to first three terms now, so we will have to find 2 and 3. So a sub 1, a sub 2 is equal to 3 times 2, which is actually our r, the value of our r, which is raised to the power of 2 minus 1 now. How did we get our r? That is from a sub n is equal to a sub 1 times r to the power of n minus 1. Okay, so let's try to solve first for our r. Actually, we have our a sub 1, which is 3, and our a sub n is 24, which is a sub 4. And solving for our r to the power of 4 minus 1. Okay, so 24 is equal to 3r cubed. And divide both sides by 3 by 3. So r cubed is equal to, so 3 divided by 3 is 1. 24 divided by 3 is 8. Therefore, r is equal to the cube root of 8, which is equal to 2. So that is why we have our 2 here. Now, 3 times 2 to the power of 1, that is equal to 3 times 2 is equal to 6. So this is now our a sub 2. So our a sub 2 is 6. And then A sub 3 because the first 3 months, why labot si A sub 4? A sub 4 is not a part of the answer in finding the sum of the first 3 terms. A sub 3 is equal to 3 times 2 cube minus 1. So that is 3 times 2 square. So that is equal to 3 times 4 is equal to 12. So our terms now, we have A sub 1 will be considered as the addends, then 6, that's A sub 2 and A sub 3. What is 3 plus 6 plus 12? 12 or 3 plus 6 plus 12, that is equal to how much? Is the sum of the first 3 terms now. If we're going to add it, that is equal to 9 plus 12 is equal to 21. 21. So that is our answer. Okay, thank you and good afternoon.